Now that we've learned how to simplify radicals, we're going to learn another way we can solve quadratic functions. So you guys learned a while ago how to solve quadratics by factoring and then pulling each factor out. Today we're going to learn how to solve them by using the square root method. So let's remember how we solved using factoring. So I want to take a look at this first equation I have on your notes, this x squared minus 25 equals 0. So I want you to remember that this type of equation is a difference. In fact, let me do it over here. So we've got a subtraction sign, we've got two perfect squares, right? So remember that this is called a difference of perfect squares. So this is important because remember we can do that little trick where we split up the x and x, we take the square root of 25, make it 5, and then we put a minus and a plus sign. Now that we've factored it, remember in the other learning target, you take each of these out, you set them equal to 0, and then solve these little mini equations, right? And you end up getting x equals 5 and another solution of x equals negative 5. So that's one way we could solve a problem like this. Now let's say that you forget that you could factor it, right? Like let's say you look at this x squared minus 25 and you forget that it's a difference of perfect squares. Like you just completely forget that, which, you know, it happens. So I'm going to teach you a different way of actually solving this guy. And what we call this the process of undoing, like we did in a linear equation, right? Like we did up here where I undo this negative 5 by adding it over. We can do that in an equation like this. So I'll show you what I mean. So when I have this x squared minus 25 equals 0, I always want to try and isolate this x squared when I solve this way. So I'm going to undo the 25 by adding it over, just like I would if this were an x by itself already. I get x squared equals 25. Now I've got this square root. That's really the problem right here, is that I have this, let me get the highlighter here. I have this thing right here, right? And that guy is what's getting in the way of solving this. But today I'm going to teach you that there is a way to undo that. And so technically the opposite of squaring something is square rooting it. So I'm actually going to take the square root of both sides. What that does is it cancels out the squared, and I'm left with just x by itself, which is what I want. And then on the other side, I know what the square root of 25 is. The square root of 25 is 5. Now, the other thing that I want to think about here, and this takes a little bit of, stretching your logic a little bit. I know that x could be positive 5, but if I bring this out over here and I say x squared equals 5, when I plug that 5 back in for x, oops, sorry, this should be a 25. When I plug the 5 back in for x, it does work out, right? I get 25 equals 25. But there actually is one other solution, and we've already found it up here, this negative 5. Where is that negative 5 coming from here? Well, remember that if I square a negative, is it negative 5 times negative 5 still a positive 25? Yes. So in a way, oops, I don't know what that means. Wow, computer. In a way, negative 5 here is also a solution. So to show this answer, we use a symbol called plus minus. We put a little plus minus in front of the 5 to say, look, x equals positive 5 and x equals negative 5. It's a shorthand for saying that solution. If you also want to write it as this, I would take that as well, and then you can also put it in this little weird notation. Any of these notations I will accept, okay? So let's try the other one here. I'm going to do the same process. I'm going to get x alone. I'm going to add 9 to both sides. And I end up getting x squared equals 9. I'm going to take the square root of both sides to undo that root. And I get that x equals the square root of 9, which is plus or minus 3. Okay? I think that this is much easier than factoring, right? I get x squared alone, take the square root, and boom, I get my answer. Okay? But there's an issue here. We can't do this with every single problem. And that brings me to this next question of what makes equations like the above special? So what makes an equation, I'm going to highlight them up here, what makes this guy and what makes this guy special. There's something special about them, okay? And I'm going to ask you to compare these two right here. This guy we can undo. We can add the 25 over and get x alone. But this guy, we have a bit of a problem. If I set this equal to 0 and start this process, right? Subtract 25 over, I get x squared plus x equals negative 25. The issue here is I can't square root just this thing. I'd also have to square root that, and this wouldn't work. This would cancel out, but then this doesn't help me. Square root of x is hard to work with. I wouldn't know how to deal with that particularly. Okay? So this doesn't help us. It doesn't actually get x alone. So the only way we can do this square root method is if we have something like this where we are missing this term right here. We cannot have this little x right here. That can't happen. If it does happen, we can't use this method. So that brings me to the next part of being able to identify what equations we can solve using square roots. So let's take a look at each of these equations and try and see if we can do this method. So let's look at number 1. Number 1 has an n squared, that's okay, but it's got this n term, right? That's not going to work. If I add 133 over, I can't have this term, so this cannot be solved using square roots. Number 2, I see an n squared, which is okay, but I see this n term, can't have that, so number 2 can't be solved using square roots. Number 3, I see a p squared, and I just see two numbers. Without the x term or the p term, this can be solved using square roots, right? I can add the 21 over, etc., and I can keep going. So this can be solved using square roots. Number 4, I'm looking for that single term with the variable, and it's right there, so this can't work. I can't solve using square roots. Number 5, I'm looking for an x term or a variable that's by itself that's not squared. I don't see one, so we can solve this equation using square roots. And number 6 is interesting. Number 6, we're actually missing the v squared term. Where's the v squared term? It's not there. In fact, if I wanted you guys to solve this and get v alone, you could do that by just showing this work. In fact, this equation is not quadratic. This equation is actually linear. So we can't solve it using the square root method, but we could solve it just using what we've learned in middle school. Okay, so it's really important that you be able to recognize. And by recognizing that, I mean you have to notice that there is no middle x term. Okay? If you don't see it, then you can totally solve it using square roots. So let's do a few more examples of this, because you're going to see some interesting things coming up. It's not just going to come out to be nice even numbers all the time. So let's take a look here at 6 problems that do some interesting things. All right, the first 2 are going to appear pretty normal. The first 2, I've got an x squared minus 16. I'm going to add the 16 over. This cancels out. I get x squared equals 16. I've got just the x squared alone, so that cancels out. I square root both sides, and I get x equals plus or minus 4. The second one, very similar. I'm going to add the 5 over. I get x squared equals 1. I know this seems strange, but when you follow the steps and take the square root of both sides, this is okay because the square root of 1 is 1. So you end up getting x equals plus or minus 1. Now these are the ones that we like. We like the ones that come out to whole numbers because we don't have to worry about fractions or radicals, right? The third one, we've got a little bit of a different step. Instead of adding or subtracting over, to undo this, I have to actually divide by what's in front of the x squared, because that cancels out and I get x squared alone. Okay? Negative 98 divided by negative 2 is positive 49, which is super convenient because 49 is a perfect square. So I get x equals plus or minus 7. Okay, number 3, this is a 3-step problem. I'm going to add the 108 over. I get 3x squared equals 108. Then I have to divide. I get x squared equals 108 divided by 3 is 36. Again, very nice because that's a perfect square. And I get x equals plus or minus 6. Okay, now the next two problems do something extremely interesting. Okay, so just pay close attention here because they look different. The fourth problem, I'm going to start solving the same way. I'm going to add the 5 over. I get 7m squared equals 350. When I divide both sides by 7, I get m squared equals 50. Now, when I take the square root of both sides, 50 is not a perfect square, so I end up getting m equals the square root of 50. Now, this is where our last learning target comes into play, right? You have to reduce this square root of 50. You can't leave it this way. So I'm going to take square root of 50, and I'm going to split it up into the square root of 25 times the square root of 2. And I end up getting square root of 25 turns into a 5, and square root of 2. Now, to be perfect, I have to put that little plus and minus symbol in front of it, because I have the positive solution and the negative solution when I take the square of something. Okay, so you always have to remember to reduce. Okay. All right, now this next problem, I've got x squareds on both sides. So what I'm going to do, I've got to get it set, I've got to get those x squareds together. So I'm going to actually subtract this x squared over here. These cancel out, and I get 5 minus 1 is 4x squared. Bring down the minus 1, and I get 0. Now I'm going to start isolating x squared, so I'm going to add the 1 to both sides. I get 4x squared equals 1. Divide both sides by 4, and I get x squared equals 1/4. Now don't freak out because it's a fraction. You're going to do the same thing. You're going to take the square root of the left, and then you're going to take the square root of this entire fraction. Now, we learned in the last learning target that that's the same thing as square root of 1 over the square root of 4 and splitting them up. Well, the square root of 1 is 1. The square root of 4 is 2. So you get an answer of plus or minus 1/2. Okay? So be prepared for fraction answers. Be prepared for radicals that you have to reduce. We've got one last thing that will happen when you're trying to solve with radicals. Okay? And you've never learned this before, I don't think, and that's okay. This is an Algebra 2 topic. It's pretty cool. So let's take a look here. I've got this x squared plus 4 equals 0. Seems really simple, right? I'm going to subtract the 4 on both sides. I get x squared equals negative 4. I take the square root, and I get x equals, I have no idea. The reason I have no idea here is because, remember, a square root means that you're multiplying the same two numbers to get this negative 4, right? So I want to figure out what two numbers give me negative 4. So let's try 2 times 2. Does 2 times 2 equals negative 4? No. How about negative 2 times negative 2 equals negative 4? Nope, because 2 negatives make a positive. The only option I know is negative 2 times positive 2, but these are not the same number. So there's actually no possible number that if I multiply it by itself, it works. It doesn't exist here, okay? So we can't take the square root of a negative number. So when I get a radical like this, the answer really, you're going to write, is no real solutions. Now, when you get to Algebra 2, you're going to learn that these are called imaginary numbers. Because we have no real numbers. And the reason they're imaginary is because we kind of know something exists about them. And I'm going to show you that in the graph. So I'm going to go ahead and graph this equation. So here's my equation. I'm going to rewrite it. I've got x squared plus 4 equals 0. So I'm actually going to write it like this. I'm going to replace that 0 with a y, because that will help me graph this. So I'm going to go to my calculator. I'm going to hit y equals, and I'm going to plug in x squared minus 4. Oh, sorry, not minus, plus. I'm going to go ahead and graph this here. Now, you're going to notice that this graph looks like this. I've got a 4 here. I've got 1, 5 here. I've got 2, 8. So these are my points. And it looks just like the graph I have on my calculator, right? Now, you'll notice, we've talked about this before, does this graph have any x-intercepts? It has no x-intercepts at all, which matches our answer, right? X, it doesn't ever cross the x-axis, so there's no x-intercepts. Okay? We can use imaginary numbers later in Algebra 2 to help us find a variety of things. It's not going to be really clear right now, but when you're a junior and you take Algebra 2 and you learn about this kind of stuff, it actually brings up some really interesting math. For right now, I just want you to be able to put this as your answer. That if you get something where you can't take the square root of a negative, I want you to put no real solutions. And it's important in saying just no solutions, because there actually is a solution, we just can't talk about it yet. So we've got to use this word real. It's extremely important there. Okay? That's about it for this learning target. It's not too terrible. Please don't ask me to do odds or evens only. I think every problem in here is pretty important. And good luck.